Welcome back. In this video, we're going to talk about the Bronsted-Lowry model of acids and bases. This model moves beyond simply looking at ions in water and focuses instead on the dynamic relationship between substances, specifically how they trade protons. In this model, an acid is defined as a proton donor. It gives up an H plus ion. A base is a proton acceptor. It picks up that H plus ion. You can think of it like a game of catch, where the acid is the pitcher and the base is the catcher. And remember, because H plus has no electrons, it is quite literally just a bare proton. I love the heads or tails analogy for this. An acid and its conjugate base are like two sides of the same coin, connected by just a single proton. When an acid on the left side of an equation gives up its H+, it becomes the conjugate base on the right. Likewise, when a base on the left accepts a proton, it transforms into the conjugate acid on the right. To identify these pairs in a reaction, you just need to count the hydrogens. Look at HCl. On the product side, it has become Cl-. Since it lost a hydrogen, it must be the acid, and Cl- is its conjugate base. Water, H2O, became H3O+, meaning it gained a hydrogen. Therefore, water acted as the base, and H3O+ is the conjugate acid. If you're given a molecule and asked to draw its conjugate base, follow this simple two-step procedure. First, remove one hydrogen from the formula. Second, lower the charge by 1. For example, if we start with neutral HF, removing the H gives F, and changing the zero charge to -1 gives the fluoride ion F-. If we start with HSO 4-, removing the H and dropping the charge from -1 to -2 gives the sulfate ion SO4 2-. To draw a conjugate acid, we simply reverse the process. First, add a hydrogen to the formula. Second, increase the charge by +1. For the cyanide ion, Cn-, adding an H and moving the charge from -1 to 0 gives HCN. For water, H2O, adding an H and increasing the charge from 0 to +1 gives the hydronium ion H3O+. Now that you can track these protons, you're ready to look at how strong or weak these electrolytes really are.